Greatest common factor. GCF, or greatest common factor, is a concept that becomes absolutely necessary to use to perform many different types of algebra problems. A factor, specifically a factor of a number, what that means is that it can be any number that number is divisible by. Remember, being divisible by something means that you can divide it evenly without there being a decimal or a remainder. To find factors of different numbers, it becomes very useful for us to remember some of our divisibility rules. In order for a number to be divisible by 2, it must be an even number. In other words, it must end in 0, 2, 4, 6, or 8. Some examples of even numbers include 16, 20, 418, 2,112. Because all of these numbers end in an even number, they must all be divisible by 2. The rule for 3 is kind of interesting. To determine if a number is divisible by 3, you must add up all the digits. If that sum is divisible by 3, then so is the number. For example, 27. If you add the 2 digits, you get 9. Since 9 is divisible by 3, so is 27. For a bigger number, like 2,172, again, add all the digits together. 2 plus 1 plus 7 plus 2 is equal to 12. And since 12 is divisible by 3, so is 2,172. There's 2 rules for 4 that might be of some help to you. The first was especially good for big numbers, like, say, 428. To check if something's divisible by 4, just look at the last 2 digits. If 28 is divisible by 4, then so is 428. In this sense, it wouldn't matter what combination of numbers went in front, as long as the last 2 digits is divisible by 4, and so would the larger number. If you have a calculator available, the rule I like to use is to divide the number by 2 twice. Take, for example, 48. If I divide it by 2 once, I get 24. If I divide by 2 again, I get 12. If you're able to do that and divide by 2 twice without getting a decimal, the number must be divisible by 4. I like this rule especially when I have a calculator available. The rule for 5 is very easy. In order for a number to be divisible by 5, it must end in 5 or 0. In fact, it doesn't matter how large it is, as long as the number ends in 5 or in 0, it will be divisible by 5. The rule for 6 is really just based on 2 and 3. In order for a number to be divisible by 6, it must be divisible by both 2 and by 3. Because it ends in an even number, it must be divisible by 2. To check for 3, remember, add all of the digits. 6 plus 1 plus 2 is equal to 9. Since 9 is divisible by 3, so is 612. Since both 2 and 3 are factors, 6 must be also. 7 is a bit tricky. In fact, teachers don't usually even teach a divisibility rule for 7. But it is kind of amazing that this trick does work every time. Let's take a big number, like 217. To determine if it's divisible by 7, first look at the last digit in the ones place. You need to double it. Also, look at the remaining numbers. Kind of makes it 21. Subtract your two numbers, the 21 minus 14. If the number you get when you subtract is either 0 or divisible by 7, then so is the number you started with, 217. Let's try another one. What about 714? First look at the last digit and double it. Also, take the remaining numbers, making 71. What is 71 minus 8? It's 63, a number that is divisible by 7. So must be 714. Don't worry if you can't remember this trick. You can always use a calculator to test as well. For 8, the trick is very similar to 4. Try dividing your number by 2 3 times. For example, 32. If we divide by 2 once, we get 16. Divide by 2 twice, we get 8. Divide by 2 again, and you get 4. If you are able to divide by 2 3 different times without getting a decimal or a remainder, then you know that the original number is divisible by 8. This becomes again very handy, especially when you have a calculator. The divisibility rule for 9 is the exact same as 3. If you have a small number, add up the digits. If the sum is divisible by 9, then so is the original number. It even works for larger numbers. If you add all the digits again, you should get 18. Since 18 is divisible by 9, so is 1,827. Divisibility by 10 is probably the easiest. The rule is that it doesn't matter how long the number is, but as long as it ends in 0, it's divisible by 10. Now that you know your divisibility rules, you're ready to find the GCF of two numbers. The first thing you need to do is to list out all of the different factors of each number. Pause the video and see if you can go through your divisibility rules and list every single number that is a factor of 42 and every single number that would be a factor of 28. If you're going through your divisibility rules, it shouldn't be too difficult to come up with 1, 2, 3, and 6 as factors of 42. For the larger numbers, the bigger factors, try using a calculator. Divide 42 by each of those factors you found, and you'll be able to find the larger factors that go into 42. Once you have all of the factors from both lists, you need to circle the ones that they have in common. Both lists have 1, 2, 7, and 14. This leads us to the last item. The answer, or the GCF, is simply going to be the largest of those numbers that you circled. In this case, the GCF is 14. It is the greatest common factor. Using these steps will always get you the greatest common factor. The hardest part is figuring out all of the factors in the original list. If you need more help, just pick a couple of numbers, and using an internet GCF calculator, you can quiz yourself and test yourself on your ability to find the GCF. If you need more help with divisibility rules or finding the greatest common factor, see your teacher in school and ask questions.